Okay, dear students, how are you? Nice to see you for this tutorial. So I just have brought solutions for one mid exam. So as usual, you need to support this tutorial program just subscribing and sharing and liking and also giving comments. So I'm now directly going to the solution of this mid exam. So as you see, this sort of mid exam is going to have the following fill in the blank questions. As can be shown, there are 6 different kinds of fill in the blank parts, so you are expected to put your simplified and completed answer over here. And next from that, there are 6 different kinds of workout questions, so you are supposed to calculate these questions in a better way. So throughout this tutorial program, I'm going to show you how all this can be done in a better sense. So here I begin from the first one. So the first question says, given vector A as 1, minus 2, 3, and vector B as 3, 1, 2, and these two are in R3, then you are asked to find the scalars x and y such that another vector C, which is a linear combination of these two vectors A and B, is a non-zero vector and orthogonal to vector B. So here you are supposed to find the values of x and y. So I'm going to show you how this can be done. So here comes the solution. Students, you have been told that C is the linear combination of these two vectors A and B, and we are using here multipliers x and y. So x and y are clearly real numbers. So C is now x times A plus y times B. So what I'm going to do is I need to multiply vector A by x. So x in times A is going to come, plus y times B is going to follow. So this makes this one, look, x times 1 is clearly x, and this is minus 2x, 3x. Here we do have 3y, y, and 2y. So as you are taking the sum, you are going to have this x plus 3y. You simply add the x components, y components, and the components together. So this is going to be x plus 3y, and this is minus 2x plus y. 3x plus 2y follows. So this is nothing but it's a vector C components. Now you have been told that this vector C is orthogonal to this vector B, so the dot product is 0. So you need to recall how you can carry out dot product between two vectors, right? So this is how it is done. C dot B is 0. So this is what you are having for C. So B comes directly from the given one. Look, here are the components for B. So I'm going to write this as it is, 3, 1, 2. So take now the dot product of these two. So what you need to do is you need to multiply the x component of this one with the x component of the second vector. So 3 times x plus 3y is going to come, and then you use plus. 1 times minus 2x plus y follows, and plus 2 times 3x plus 2y is going to come, and this sum must be equated with 0. And here you are, 3 times x plus 3y minus 2x plus y plus 2 times 3x plus 2y. After simplifying this, you can have this expression 3x plus 9 minus 9y minus 2x plus y plus 6x plus 4y equals 0. What has been done here is I simply multiplied each of these bracket expression by the multiplier in front, by the multiplier numbers existing in front. So finally, after summing this, 3x minus 2x makes x, and here 9y with y makes 10y, and plus 4y makes 14y. Actually, I do have also extra added here, y, means 6x. Anyway, this can be added to the following one: 3 minus 2, 1, and 1 plus 6, 7. So you are going to have 7x. 9y plus y is 10y, and 10y plus 4y makes 14y. So altogether you do have 7 into x plus 2y, because you are having 7x plus 14y, so you can take 7 as a common out, and then you do have this. Now it's very simple again to divide the entire equation by 7. So in doing that, you will have only x plus 2y. So x plus 2y equals 0 means just taking this plus 2y to the right, x equals minus 2y is going to come. So look, you are now having a lot of different real values for x and y, because we are not having specified values here for x and y. So we are free to take any, right? Any x and y values, except the case of taking x and y both to be 0, because we are here asked to find an non-zero vector c, right? If we are looking for a non-zero vector c, x and y must be free from 0. Okay, the two can't be 0 at the same time, because if you are making the two 0, your c is going to be 0. Since your intention is to find a non-zero vector, you are free to use any number in place of x and y, except the case where c both can be 0. So your answer can be written in terms of the following way: x equals minus 2y, and y is again itself, but your y can be any sort of real number except 0. So for instance, you are free to take any non-zero here in place of y, but in x there you need to take minus 2 multiple of what you take here. Okay, for example, if you are taking number 3 in place of y, here in x it will be minus 6, because minus 2 times 3 is going to be minus 6. And if you are interested to use number 2, for instance, in place of y, you are free, because 2 is a real number different from 0. Then here x is going to be minus 4. So whatever non-zero real number you may use here in y, your x is going to be minus 2 times the one you are taking here. So this is going to be the final answer for question number 1. Now proceeding to number 2, we are having another question. Look, you are given that magnitude of a as a vector is 2, and the norm of vector b is 1. And here c is another vector which actually is the cross product of the two vectors a and b. And you have been also told that the angle between these two vectors a and b is pi over 3, and the two vectors are in R3. So the question is to find the magnitude of a plus b minus c. So in order to find this one, let you see how I did. We know, dear student, that the norm of any vector is the square root of the dot product of, you see, the vector as can be shown. Remember, in our lecture class we said that the norm of u is equivalent to the square root of u dot u, which actually is u squared, right? So that has been used here directly. Just consider a plus b minus c as u, vector u. So if you consider the norm of u here, if you consider a plus b minus c as u, the norm of a plus b minus c is going to be norm of u. So that is the square root of u dot u, right? So you are having now a plus b minus c, a plus b minus c. So what we need to do is, you see, you can multiple these two, you can apply the distributive property. A plus b can multiple with what? A plus b, as you see. And again, a plus b can multiple c here, so you do have minus of a plus b dot c, and again minus c can multiple a plus b. Look, minus c can multiple a plus b, and minus c can multiple again minus c. So what I did here is I just have simply applied distributive property, and from this we can have the following one, students. We know that a dot a again is norm of a squared, because a dot a is norm of a times norm of a times cosine of the angle between the angle a and angle a, which actually is 0. So it's going to be norm of a squared, plus a dot b plus b dot a is going to be 2 times a dot b, plus b dot b is going to be norm of b squared, right? So this is actually obtained from a plus b dot a plus b. But now here, students, again I can undergo distributive property for these two. So this is negative, so take it as it is. Then a dot c comes, and this is minus, because minus times plus is minus. B dot c follows, and here minus c dot a, and then minus c dot b can come, and finally minus c dot c is going to be norm of c the whole squared. But beloved one, there is one thing that you need to underline here. You have been told that C is a Cartesian, the cross product of these two vectors A and B. And as you know, if C is the cross product of the two, C is perpendicular to both A and B. So if C is perpendicular to A and B here, C dot A or A dot C and C dot B or B dot C, these are going to be 0 because the cross product of two vectors is perpendicular to the two vectors, right? So because of these concepts, this goes to 0. A dot C goes 0 and B dot C also goes 0, and here also C dot A at the same time C dot B, all these go to 0 because C is perpendicular to or normal to these two vectors A and B. So whenever you combine C with C, these two vectors A and B using dot product, it turns to be 0. So here, from this expression, again this one, together with these two, everything here goes to 0. So what's going to come here is, you see, this expression alone. Norm of A squared plus 2A dot B plus B squared minus C squared, right? The idea is explained over here. Now students, norm of A is already determined and the norm of B is also determined. Now we need to determine what A dot B is. Since we are given the angle between what? A and B, we can determine what A dot B is. You know that A dot B is norm of A times norm of B times cosine of the angle between these two vectors A and B. So everything is given. Norm of A is 2, norm of B is 1 because both are given here as you see. And cosine of the angle between the two is cosine of pi over 3. Remember that pi over 3 is 60 degrees. So cosine of 60 degrees is 0.5 or 1 over 2. So 1 over 2 can cancel 2 and then 1 can come. So we knew now A dot B. So we can directly take this number where in place of this A dot B. And then we can have this one. Look. Here again the norm of C must be determined. And in order to determine the norm of C, look, norm of C the whole squared is norm of A cross B the whole squared, because we knew that C is A cross B because that's been already given here. So norm of norm of A cross B the whole squared is the square of norm of A times norm of B times sine of the angle between the two, because A cross B is defined as norm of A times norm of B times sine theta, where theta is the angle between the two, and everything is straightforward. 2 times 1 is going to come and sine 60 degrees is going to follow, and we know that sine 60 is root 3 over 2, and this expression must be squared. And finally students, you will get this to be 3 because radical 3 is going to come because 2 is cancelled by 2, so squaring that you will have 3. So this norm of C square is obtained to be 3, so it's a matter of again taking this and plugging here, right, directly. So everything is now obtained. We knew what A dot B is, so already know it's 1. Norm of A and norm of B are already determined here from the given information. Now we can know, again, norm of C is already determined, so we can determine these results. And when we come to, you see, the output, you are going to have this expression. Look, here we are having, look, norm of A squared is 4 because norm of A is 2. So squaring that to be 4, and this is 2 times 1, right? 2 times 1, because A dot B is 1. Norm of B is already 1, so its square is 1 again, and this is already determined, it's 3. So the next task is a matter of simplifying this. And look here, 4 plus 2 times 1 is 2, so it will be 6 plus 1, 7, 7 minus 3 is going to be 4, right? So radical 4 is going to come. Basically, radical 4 is 2. So clearly, the norm of A plus B minus C was our intention, and here we go. So dear students, in order to obtain such kind of, a solution of such kind of questions, you need to recall the basic properties of vectors, right? I hope you have understood in a better sense.